Hi there. In this, the second of my series of short tutorials on how to animate in Blender, I'm going to talk about physics simulation. So to begin with, let's just put something into the scene. I've got a basic floor here already. So I'm going to add a simple UV sphere to begin with. We'll bring this up to here and we'll give it a basic material and we'll give that a nice red material. Press T to bring up the left-hand menu and I'll set this to smooth shading. And let's make it a little bigger. So I'm going to put it sort of about here, somewhere in the air, and then press play, and of course nothing happens at the moment. With the left-hand menu, which you bring up and hide with T, you should have physics available if you've got Blender 2.79 loaded. And you'll notice under here we've got various options. So with my sphere selected, first option I'm going to click is Add Active. And then I'm going to press play again down here. And you can see it starts to move, but obviously it just fell through the floor. So that's because we've created a physics simulation world and we've put one object in it, which is this sphere, and you can see it's part of the physics world because it's got a green outline. You can see if I go into wireframe mode, the wireframe is in green. So I'm going to select the floor plane now. If I selected the same, Add Active, watch what happens. The floor actually falls away as well, which is clearly not what we want. So I can click Remove and then I can click Add Passive. So passive, you see it's got the little green outline now. Passive means that it will take part in the physics world in terms of collisions, but it doesn't respond the way a dynamic object that perhaps bounces around will. So let's see what happens when we press play now. And you can see the ball stops when it hits that. It just stops dead, so it's not a very convincing physics simulation at the moment, but there's some things we can adjust. So the ball is hitting the floor around the 50th frame, so let's just limit this to 75 frames for the moment and then just click play and let it continue. So if we come over to the physics options over here, we can see we've got some options available for the ground, and if I select the object, there's some options available for that as well. And you'll notice dynamic is already selected. If we wanted to use one of the objects from our previous simulation, perhaps as a passive object that hits a dynamic object, we would need to click animated here in order for the physics simulation to know that it was moving. But at the moment, this is just an object that we're setting up and letting go, so we don't need to worry about that. By default, it selects convex hull, and I'll talk a bit more about those in a moment. But you notice we've got an option down here called bounciness, and clearly that's set to 0 at the moment. So let's try 0.5, and it'll cycle round again. And one other little thing you may have noticed is this orangey yellow line appearing down here. If I change any of the options, say turn bounciness up slightly, it disappears apart from a faint line and then reappears again as it scans through. So that's basically a cache being built up so that Blender doesn't have to recalculate everything again. It's stored its calculations. So let's go to our passive object now. So I selected my ground plane. And you notice we've got pretty much the same settings there as well. So if I set 0.5 on that one, and now we're starting to get a bounce. And it's even rolling around slightly. So one thing of extra interest, if I go into orthographic view, which removes all the parallax, that green line is where our ground plane is. And if I zoom in, you can see our ball is actually not quite hitting that. And it's hovering just above it. So with all sorts of physics, you need to understand collisions, or the system needs to know whether something has hit something else. And to do that, it needs to know the shape of the object, where it is, and how close you want to trigger a collision. In addition to that, there is a, if you like, a sort of sample rate that relates to how many calculations it will do per second. So over here in the scene settings, under rigid body world, we have a number of options to change as well. Now, these aren't going to change how high that ball hovers over the surface, but what they will do is change how many times Blender checks in a second, or between frames if you like, for a collision. At the moment, it's checking 60 times a second. We've got 25 frames a second, so it's checking more often than there are frames, which is typically fine. but it can check a lot more often than that. So if I put that number up, it checks more often. And we've lost our bounce again, and that may just be a little quirk of calculations. One of the things about physics is it doesn't always get it right. So one of the other things we can do is look at solver iteration. So this is where it goes round the calculation multiple times in order to refine the result. So we can put that up all the way up to 100, and it's basically a more accurate calculation. I'm not entirely sure about the maths of this option, split impulse, but sometimes it can be useful when you have an unstable simulation. So you just click that and Blender will alter the way it does its calculations in order to hopefully remove a problem, but you normally don't need to use that. And the speed is obviously the speed that the simulation is running at, so 1 is, if you like, real time. We could set this to 0.5 and you see it's almost as if it's in slow motion, or 2, and it will obviously be running more quickly. So let's put this back to a more normal solver iteration, and we'll put it back to 60 steps per second because that was giving us a good result. If we go back to the physics simulation now, I'm going to select my object and I'm going to add a modifier which is a subdivision surface modifier. So under modifiers, add subdivision surface. So I've added extra geometry. I did quite a bit of extra geometry there because I've noticed it sort of falling over, and that's because of the facets. So I'm going to apply that now. And you may have noticed the cache refresh down here. Something else we can do over here is calculate mass. So if we click that and then we say what we think it might have been made of, let's say copper, then the relative mass of an object will be calculated. So if you wanted perhaps a copper ball hitting a polystyrene one, then you would set them to those appropriate materials, and then if they were the same size, for example, the copper ball would weigh a lot more than the polystyrene one. And if we go to the physics properties, we can see it set it to a mass of an arbitrary number, 36,000. So obviously this is rather a large ball. If I make the ball a little smaller and apply rotation and scale, so applying particularly scale is very important with physics simulations because they don't always work as expected unless you've done that. See, now we're getting a bit more of a bounce out of it, but we can still see it's hovering just above the surface. So how can we adjust that? It's using a default collision margin at the moment, and we can turn this setting on and adjust it. If you have the collision margin set to 0, you can often get unstable simulations. Not always, but can often be when there's more complicated things going on. So if I set that to 0 and it redoes it, you can see that's not quite worked anyway, and other than that it seems to be okay. But if we now go to our surface and we set that margin down to 0 as well, and just move it a little bit just to make the simulation reset, it's actually working. Because it's a very simple simulation, it's not giving us any problems at the moment. And you can see a couple of things. So first of all, if I go through the frames one at a time, you can see it actually goes through the object, which is not ideal. It probably looks fine when you're looking from above because it just looks like the ball's flattened slightly or the surface has sprung slightly, but obviously it isn't entirely accurate, and that goes back to that number of frames per second. But if we carry on, you can see it actually settles right on the surface. So that might be fine, but in reality you're best advised to have at least a small margin. 0.04 is the default. If I set that to 0.01, I don't necessarily need the collision margin on the object. And we start it again, and we can see now that it's hovering, it's all settling slightly above the surface. But we're still getting that problem of it going through the object. So if we go back to our scene settings, and let's put the steps per second up to 120. Recalculate. And let's have a look at how that bounce did now. And that's not going through the surface anymore. It's not really giving us much of a bounce either. We are getting a little bounce. So we can see that actually worked. So just going up to 120 samples, didn't need to go up to 1,000, has given us a more accurate representation. Obviously it's still hovering above because I've set that to do so. And how much you want it to hover above, obviously you can adjust that. So perhaps we go to 0.002. Press play on that and there we go. Maybe even 0.001. So that's our basic ball. We can play with bounciness, we can turn it up a bit. So I've added more bounciness to the surface. And I can do the same with the ball. There we go. And let's turn the frames up a little bit there so we can see a little bit more. We're getting a nice little bounce simulation now. So all I've done is set up the physical parameters. So what if we change the shape of this ball? We'll start it off a little lower down. I'm going to select that center vertex and press Ctrl+ and just select out to perhaps about there, maybe a bit more. Press X and delete vertices. And then I'm going to select all the vertices along there and press F to close that off. I'm going to Ctrl A and rotation and scale, so that's applying rotation and scale, and press play. At the moment it's not having any effect, but I'm also going to add something else. So I'm going to add a cube, put that somewhere about here. It's going to be another passive object, and I'm going to give that side of the cube a slope. So we'll pull that down to about there. I'm scaling it up on everything except for the Z-axis, and now I'm just going to pull it down to coincide with the floor plane. It's actually going slightly through it, and that's fine. I'll give it a yellow material, and then I'll say add passive. Come over to here, we'll set the margin to 0.001, same as the floor, and we'll put the bounciness at 0.5. So let's press play now, and that's okay. And I think we can even go up to 250 frames now. And we can see our object is moving around and rattling around and generally working. So a little bit more about the shape. So this is called convex hull. This is a relatively simple collision boundary, but there are simpler ones. So if it was a perfect sphere, I'd actually set this to sphere. This just makes the calculations for Blender easier. So you can see a sort of complete sphere, very low res sphere, has appeared around my object. So let's see what happens when I press play now. And you may have just been able to see it's as if the part of that sphere that I removed has come back, because it's just rolling normally. It doesn't recognize that part of the sphere has been cut away. I could even set it to perhaps box, and you notice there's a box around my object now, centered around the origin point. And let's press play now, and you can see it doesn't behave as you'd expect at all. The most accurate is mesh, but that also means Blender has to look at each of the points on the surface of that object. And you might need that for a more complex object, but you can see even there, it was taking a little while, but it gives you a much more accurate simulation. Generally with simulations, especially if you're going to add a lot of things in there, you want to keep the number of calculations under control. You don't want to do any more than you need to. It's a bit like render time. The more detail that you render, the longer it's going to take to render. And if we go back to the beginning and then say convex hull, that will work for most simple shapes. And you can see it works for this one. But it's still a simplified version of the shape. It doesn't have as much geometry as the shape itself. So what if I wanted this to fall into something? So if I select my object here, and I'll select all those top faces, press I and scroll in a bit, so that's inset a face, press E and then left click and then just pull it down and say scale Z0 to flatten it off. Just looking from the side, bring it down a little bit. So we've now got a shape with a hole in the middle. Again, just to be sure, although it shouldn't matter too much in this case, I'm just going to apply rotation and scale in case I hadn't already. And let's just press play and see what happens. That actually seems to be working. And the reason that it's working is because we've got mesh selected by default for this object, which is, as I've said before, the most complex. If I set this to box, you can see we've got our box shape out there, and I press play and my little sphere just lands on the surface now. It doesn't even recognize that there's a slope there, let alone that there's a hole. But if I select convex hull and restart, it still doesn't quite work because effectively it doesn't know about the hole. It knows that the object has this slope on it. You can see it's managed to land where the surface of the object was, but what it's not able to realize is that there's a hole in it. So if you need to actually recognize with your simulation these more complex shapes, that's when you're going to need things like mesh. These are, if you like, primitive shapes, which are often useful, but for some things you will need mesh. So we go back again and we can see the object actually falls inside our little box. So of course something else you can do with simulations, if I just change this object again, I'm just going to fill that in and let's just make sure our simulation's going fine. It is. So we can build destroyable surfaces. So let's add a simple cube, scale Shift Z just to scale on everything except for Z. And this is a common thing to see in Blender. I'm just putting it slightly above the surface. Let's give it a material and we'll give it a blue material this time. So we'll come over to here and add active, and then we'll press play before we do anything else. And that was fine. And you noticed it wobbled a little bit there when it got hit. So let's make our spheroid a little bigger. Again, apply rotation and scale. And have another look at what's going on. Good, that knocked it over. So we can put several of these here. And perhaps rotate those on the Y axis, bring them over here, and I'm just going into orthographic. Now what I'm doing when I place these for this sort of thing, so I'm actually leaving a small gap. I'm just going to put that a little higher, just to give us a bit more time. I'm leaving a small gap because if I don't, what can often happen is they go flying off if you've got one object buried inside another and they're active object, or one of them is an active object. So it's best to leave just a tiny little gap and then they settle together when you start the simulation. Let's see if that worked. You see it all dropped down. And that worked fine. Let's give this ball a little bit more mass. So let's make this 50,000 and see what happens now. And it's still working. And perhaps we want to delete all those vertices, close that face, and then make this slope a little more extreme. Apply rotation and scale, and let's see what happens. And there we go, we've just about managed to knock all of our little blocks over. A couple more things about the physics simulation. We also have the setting for friction. So if I set that up to maximum for the cheese shape, this block here, and press play, you can see that actually slowed that object a bit. Perhaps that slope's a bit too extreme to really show it. I'm going to set the bounciness down to 0 as well. And the same on the object there. You can see it's reducing some of the energy, and I'm going to set the friction on the object up to maximum as well. And there you go, you can see we've lost a lot of energy now, because it's only barely managing to knock these objects over. On the other hand, I can put friction down to 0. I'm not worrying about bounciness at the moment. And you can see it just slips through as if it's landed on some grease or something like that. It's not even bouncing. And then if we turn bounciness up as well on both objects, it actually just bounces straight into them. So you can get some quite interesting effects by doing this. And perhaps we'll turn bounciness down to a more reasonable level now. Because there's no friction, it's not causing it to rotate, so let's give it a little friction. And there we go. And you can build some quite complex structures. So one other little thing about physics simulations, you may want multiple simulations going on, but you may not want them all to interact. I can change what collision group objects belong to. So for example, if I select this object, you see it's in this collision group here at the moment, but I'll set it to this one. And then go to this one, and this one, and this one, and this one, and this one. If I press play now, you'll notice they just fell through the floor. That's possibly not what you were expecting to happen, but of course the floor is part of a different collision group, a different physics simulation if you like. So I could move the floor to the same collision group, and I think we know what's going to happen now. All of the active objects just fell straight through, except for those that belong to this collision group. I'll put the floor back to there. I'll now change this object to the second collision group. Press play, and you can see it's bouncing on the floor, but it's not recognizing the yellow shape. I've just changed the yellow shape, and now it's recognizing these. So you can have quite a bit of fun there, changing what is affected by what. And you've got quite a lot of collision groups there to select from, and it works the same way as the layers down here. So then the final thing is about animated objects. So if I add an icosphere, we'll make this a nice green color. I'll apply rotation and scale, and I'll keyframe its current location. I'm going to remove this object from the scene now, I think, and I'll remove this one as well, just because it's simpler that way. So I press I, record the location, then we'll go to frame, and then we'll go to frame 50, move it over to here. You notice it's going to pass through those. Press I and location again. So we go back to the beginning of the animation, our object just does that. Let's change the floor collision group back to normal, as well as all these objects back to the collision group that we are using, the main one. So they just sit there after settling, and our animated object currently just moves through them. So the next thing we want to do is add passive to that object. So I've just done that, and let's see what happens. Nothing. So we've said add passive, so you'd think these should interact with it. These are active objects, this is a passive object. But as I mentioned earlier, we also need to tell Blender that this is an animated object, not just to base its calculations on the initial position of this object. So I've clicked animated now, and you notice it's now pushing its way through all of those objects. And if this object was an object that was changing its shape, we need the setting here to be deform. It's the default setting, but it will basically use the changed shape of the object. But you can just use the base shape or the final shape if you're using shape keys, which I'll demonstrate in one of my later videos. So I hope you found that useful. If you did, let me know, and I'll see you in the next tutorial. Thanks a lot. So I hope you found that interesting. If you did, let me know. If you enjoy these tutorials, don't forget to click like and subscribe. I also have a Facebook page and a Twitter account, and I now have a Patreon page as well, and I'll provide links to all of those in the description below. So I'll see you in the next tutorial. Thanks a lot.